ठीक है, so low melting and boiling point, no electric conduction. They're mostly gases. ठीक है, so most of them happen to be most of them happen to be gases. Or low boiling point or volatile liquids. Very rarely do you have solids as well. ठीक है, volatile liquids. Anyway, so this was the structure. It's a simple molecular lattice, and they've got weak intermolecular forces in the middle. The molecules are kind of independent. They're all independent of each other. Achha, the first thing, covalent dot and cross diagram, right? Okay, that's the first thing. Let's start with the very basics. Covalent dot and cross diagram. So, covalent dot and cross diagrams. Or what did I tell you about covalent molecules? They're formed when you have a low difference in electronegativity. So covalent is going to be when you have kitna tha number kya tha? That was 1.7. So it's when you have so it's going to form between any atom that has a low difference in electronegativity, and the number was less than 1.7. Okay, so you're going to have a covalent molecule. But generally speaking, very generally speaking, actually, group 7 is going to make group 7 is going to make one bond. Group 6 is normally going to make two bonds. फिर आपके पास group 6 का जो outer shell है, that's got 6 electrons, so it needs just 2 electrons. Group 5 needs 3 electrons, so it's going to make 3 bonds. And then you've got group 4, which is going to make 4 bonds. But remember, I told you that these covalent bonding is not limited to these any atom that's got low difference in electronegativity, that's going to form covalent bonds. Okay, so यहाँ पे मैं लिख भी देता हूँ कि ये जो मैं बात कर रहा हूँ ना, that's generally, that's not always. And I'll explain when this will not happen. I'll explain that as well. Okay, so when you make dot and cross diagrams, group 7 makes one bond, right? So if I have a fluorine atom, remember we're trying to draw dot and cross diagrams. So if I've got a fluorine atom, the fluorine atom is in group 7 and it's got 7 electrons already. As it's got 7 electrons already. So there's only room for 1 electron. So there's only room for 1 electron, which is why if you have a hydrogen atom that's somewhere close to it, then the hydrogen atom will be pulled close to it, and they're going to form one covalent bond. Remember, in a covalent bond, no one is going to be able to lose or gain electrons because the difference in electronegativity is very low. Okay, so group 7 only makes one bond. So it's better when you're making covalent bonds. It's better to actually start with the structural formula, which you're already familiar with, okay, in O levels. अच्छा, इसके बारे में थोड़ा सा बता दो. हाँ जी.
सर हाइड्रोजन को ओवरलैप नहीं करना चाहिए फ्लोरीन के साथ?
किसको?
हाइड्रोजन को
कर रहे ओवरलैप?
ओवरलैपिंग जरूरी होती है ना, यानी
नहीं, ओवरलैप नहीं हो रहा।
सर वो तो शेल के
अच्छा,
साथ।
अच्छा, वो तुम कह रहे हो इस तरह हो जाए?
जी
इट्स
सर।
इट्स द सेम थिंग, आई मीन देयर इज नो डिफरेंस।
ओके।
ठीक है, उसमें कोई फर्क नहीं है एक्चुअली। व्हाट मोस्ट ऑफ द टाइम हैपेंस इज they don't even draw the circles, they just draw a Lewis diagram. This is known as a Lewis structure. ठीक है, उसमें भी confusion हो जाए, sometimes they don't even draw circles. So Lewis structure of, let's say, I'll just give you an idea of a Lewis structure. Okay, this one, if you can see this one. Okay, they're not even drawing the Malik to ye hai na. Okay, so they've drawn the circles, right? But then you have this as well, which is kind of exactly the same. If you can see this, but they don't even draw the circles. Is that clear?
जी सर। सर ये मैं एग्जाम्स में कर सकता हूँ?
ये क्या कह रहे हो?
जी सर। सर मैं पूछ रहा हूँ कि ये हम एग्जाम्स में कर सकते हैं?
हाँ,
ओके।
it's up to you. I mean, the circle is the least relevant part of the whole thing. ठीक है, as we're learning how to draw dotting cross diagrams, which you already know. ठीक है, I said this thing, ये जो the box over here, remember this usually applies to period 2 elements. The number of bonds that they're making. Achha, but I'll stick to this first one. Okay. So how do you make a molecule? If you have carbon and carbon is in group 4, that means if it's group 4, I'll just draw a few dot and cross diagram. If it's in group 4, it's going to make 4 bonds. If I've got oxygen is in group 6, and you should know that group 6 makes 2 bonds. So if I if I draw the carbon and oxygen or carbon dioxide molecule, it's going to look like this, that there's going to be a carbon, and carbon makes 4 bonds in total. So in the case of carbon, it's going to make 4 bonds with 2 oxygens, because oxygen only makes 2 bonds. So that's my carbon dioxide dot and cross diagram. Okay, it's just like organic chemistry. Yeah, before drawing the dot and cross diagram, make sure you draw the structural formula, because then it becomes easier. Like if it's so this is carbon dioxide, I'll draw the dot and cross diagram shortly. If the molecule is let's say HCHO, so you know that carbon in the middle would be making it's going to be making 4 bonds, and you got 2 hydrogens in this molecule, so that means there's 1 hydrogen. Okay, so you've got 1 hydrogen and there's another hydrogen. Okay, so you've got 2 hydrogen atoms, because hydrogen only makes 1 bond. And then I've got oxygen, so oxygen makes 2 bonds. So that's going to be my structural formula of this molecule. Remember that all atoms must be making the right number of bonds. So if I draw an incorrect molecule, let's say, so there's carbon, and then there is N. Then there's another carbon, and this carbon is making a double bond with oxygen. And there's an H. TK plus this one over here is making 3 bonds. That's a 3 bonds with H. And there's another bond with H. Anyways, can you spot the mistake that I've done? Remember, N is in group 5, carbon is in group 4. So what's wrong with this molecule? The one that I've drawn over here.
Sir, nitrogen must be having 3 bonds, but it only has done 2 bonds.
Okay, so nitrogen should be making 3 bonds. So there should be. So let's just randomly. I'm going to add H to it. Now nitrogen is fine. It's making 3 bonds. What's the other thing that's wrong with this molecule?
Carbon forming 5.
Okay, so carbon is making 5 bonds, right? I just remember, just start off with the structural formula first, and then you'll be and use these guidelines. Okay, you can then figure out who makes how many bonds. So, for example, if I want to draw the Dorian cross diagram of this molecule, then it's going to be simple that I have a carbon and I've got 2 oxygens on either ends. So there's a carbon in the middle, and I've got 1 oxygen, and I've got another oxygen on the other side. And I said there's carbon, this is oxygen, and it's making double bonds on either side. So double bond means 2 electrons each being shared. And the same thing over here, 2 electrons being shared, right? So that's the Dorian cross diagram. The only thing you have to remember is that make sure you draw the remaining electrons, which is that carbon had 4 electrons. Ab is case mein carbon, just once. अच्छा, इस case पे, in this case, remember to draw the remaining electrons. Just 1 second. I said, remember to draw the remaining electrons. That carbon has 4 electrons. All 4 got used up. 2 over here, 2 over here. Oxygen is in group 6. It had 6 electrons. So only 2 of the electrons are being shared. So that means there are 4 electrons that are left. Okay, for oxygen. And the same applies to the other one. That there'll be 4 electrons that will be. So that will be left for the other oxygen as well. I said now similarly, if I want to draw HCHO, that's simple as well. That you've got a carbon, you've got an oxygen, and I've got 2 hydrogens. Okay, so unko usi order mein connect them in the same order, and so this is H. There's a double bond over here, so I'm going to draw sharing of 2 electrons. There's a single bond over here. Iska I'm drawing shaded dots. So exactly follow this double bond between carbon and oxygen, single bonds on the other side. Oxygen is in group 6, so that means 2 electrons being shared. So there'll be 4 electrons that will be left. Carbon had all 4 electrons getting used up, and H just has 1 electron. Okay. So remember to follow this, and you can keep on drawing this in this way. If I have a molecule of HCN, so that would look like this. It's going to be H with C and N. So there's going to be an N on the other side. N makes 3 bonds, right? So it's going to be 1, 2, and 3, right? That's what an HCN molecule would look like. H making 1 bond, carbon making 4 bonds, N making 3 bonds. N2H4, what would N2H4 look like? And you can follow it up with the Dorian cross diagram. What would N2H4 look like? It's going to be 2 N's. N is in group 5, so that means N should be making 3 bonds. So that's first N complete, then the second one should be making 3 bonds as well. So that's it, and you can follow that up with a Dorian cross diagram. Okay? Is that clear? Ye wala part clear?
Yes, sir.
अच्छा अब एक सेकंड अच्छा अब ये कि अच्छा अब इशू ये कि slightly or you're clear enough you can make the dot and cross diagram, right? Now the issue is that I told you okay it applies to group 2 elements only. ठीक है अच्छा एक थोड़ा सा मैं आइडिया दे दूं कि if you talk about period 3 elements, remember they can expand their octets and I'll explain what that means. ठीक है, I'll explain that. So let's talk about period 3 elements. Period 3 and above. So these elements can expand their octets. Basically what that means is that if you have a period 2 element, the maximum number of electrons in a period 2 element can be 8. That's it. Okay, if the first shell number 1 has how many electrons? Maximum. Shell number 1 has maximum of 2 electrons, right? Shell number 2, on the other hand, has maximum of the maximum number of electrons that can be accommodated in shell number 2 is 8. Shell number 3, that's maximum, that's 18 electrons. And so on. Shell number 4 is even bigger in size. That's 32 electrons, right? I mean, the first shell only has the 1s subshell, 2 electrons maximum. The second shell has 2s and 2p subshells. So that's a maximum of 6 in 2p and 2 in 2s. Third shell, you're going to have 3s and you're going to have 3p as well, and you're going to have a 3d subshell as well. So that's 10 and 6 plus 2, that's 18 electrons. Or fourth that's 4s, 4p, 4d, and 4f. So the point is that if you have shell number 2, why does hydrogen only gain 1 electron? Because there's only room for 1 electron. That's it. It can't have 8 electrons. Shell number 2 can have 8 electrons. Maximum, they can have 8 electrons. So all these elements that you're talking about over here, nitrogen and oxygen and carbon, they were all period number 2 elements. The maximum electrons that they can have is 8. That's it. Okay. So if you talk about fluorine, fluorine maximum can have 8 electrons. That's it. Okay. So that's the maximum limit of its shell. But when you move towards shell number 3 can have a lot more than 8 electrons. Is that idea clear? Okay, shell number 3 is a lot bigger in size. It's got the 3s subshell, 3p subshell, 3d subshell, so it can accommodate a lot more electrons in it. And if I talk about chlorine, right? So if I talk about chlorine is 17 electrons. So it's 1s2, 2s2, 2p6, and 3s2 and 3p6, 3p5, sorry. And the third shell is kind of empty. The CD is also empty. Remember, the third shell also has D. So the outermost shell of chlorine, it's got a room available for 11 more electrons. So it doesn't really need 1 electron. It can actually accommodate 11 electrons. At least there is space available for 11 electrons. Is that clear? Chlorine can have a lot more than 8 electrons. Is that idea clear?
जी
Sir.
ठीक है, is this clear to everyone? That Zaviba, is this clear? Saad?
Yes, sir.
Achha, so remember, if you look at the oxidation states of chlorine, you'll notice that it's got a lot of oxidation states. Like agar main fluorine common oxidation states of chlorine. So you can see it's +7, +3, +5, even +7, right? Achha, so if it's got space available for 11 electrons, that does not mean that it's going to gain 11 electrons. Okay, because remember, it's pretty hard to actually gain electrons because you have to gain it from another atom. So it's very hard to gain electrons in the first place to begin with. So electrons could be freely available, and that if it's got room available. So here is chlorine, and it's got 7 electrons currently in its outer shell, right? And it's got room available for 11 more electrons. So it's going to grab those electrons from somewhere. Now, chlorine has a limited ability to actually gain electrons. It's got a certain electronegativity. It's not possible for it to gain electrons from every other atom. Okay, that's not going to happen. It might gain a few electrons, and it depends on the other atom as well. Is the other atom willing to lose electrons or not? Okay, so there's a mutual thing going on. Like chlorine would only be able to gain electrons, like if it needs 11 electrons, it can only be able to gain electrons if the other atom is willing to actually give its electrons to it. So maybe kabhi chlorine ko ek mil jata hai, kabhi sometimes it gets 3 of them, sometimes it's going to get 5 of them. So that's why it's got variable oxidation states, right? Plus 3 ka matlab it's bonded to the 3 atoms, like यहाँ पे क्रीना अगर वो ClO3, I'll drawing cross diagram of, let's say, ClO3, or let's chlorate 5. ठीक है, where chlorine is +5. So बोल के खुद ही ड्रॉ कर लेते हैं. ये मैं ज़्यादा सिंपल कह रहा था कि अच्छा, anyways, you can see over here. Let's just copy this one. Actually, now this molecule, if you look at this molecule, you notice that chlorine is gaining a lot more electrons. It's gaining, uske outer shell mein look over there, 4 over here being shared, there are 4 electrons over here shared, there are 2 over here and 2 on this side. So 4 plus 4, that's 8, 8 plus 2, that's 10, 10 plus 2, that's 12. So remember, the outer shell of chlorine can have a total of, it can have a total of 12 electrons. Okay. It can have maximum 18 electrons. So is this idea clear? Just the idea that atoms in shell number 3 and shell number 4 can have a lot more electrons. ठीक है, is this clear?
सर
हाँ जी.
तो जैसे MgCl2 होता है सर, उसमें तो मैग्नीशियम भी 2 इलेक्ट्रॉन्स डोनेट करना चाहता है, लेकिन एक और क्लोरीन एटम आके बॉन्ड कर लेता है. तो उसमें ये क्यों नहीं होता कि क्लोरीन दोनों ही गेन कर ले?
मैं भी कह रहा हूँ, it depends on the mutual. There's a mutual thing going on that if this wants to gain electrons, the other one should be willing to lose electrons, right? So if the other one is not willing to, because the Cl has to gain those electrons from Mg, right? So maybe unka jo electronegativity difference, that's just enough to actually gain just 1 electron. Is that clear?
जी.
So it all depends on that. Okay. So that is the main difference. Okay, so which is why they have variable oxidation states to begin with. So Sitrana, you've got, plus there are other things happening as well. Okay. For one thing is, I said this is what I'm talking about. अभी मैं इसे सोच रहा हूँ उसको explain करूँ कि ना करूँ. remember, if I said let's look at it this way. कि example, a question आता है, ठीक है? There's a question that usually comes, and that is that I said that is CLF7. एक सेकंड में सर्च कर लूं. This is CLF7 IF7. 1 second. 9701. अच्छा सही है. Although यहाँ पे दिया है posted outside, ठीक है? 9701 chemistry 2016. अच्छा, this one. वो कह रहे कि CLF7 is hard to form, but IF7 has been prepared, right? So they're asking why is that happening? Okay. So this is the question. There's a specific chemistry question that appeared on this. So CLF7 does not exist, or it's hard to form. But IF7 exists. Okay, that's the question. So why is that? So you've got chlorine. I said, why does chlorine not bond with 7 fluorines? Chlorine क्या करता है? Is it strongly attracting its electrons or weakly attracting its electrons compared to iodine?
Strongly.
A smaller atom always strongly attracts its electrons. Iodine, on the other hand, has a much bigger atom, but it's got a much bigger outer shell. Fifth shell, you can have a lot of electrons, a much bigger atom. Let me just draw a bigger atom. So this is iodine and this is Cl, much smaller. So Cl, that is very tightly attracting its electrons. Iodine, on the other hand, is not very tightly attracting its electrons. So if 7 fluorines come in, remember, iodine is shielded. It's much bigger. It's got a lot of inner shells. So when fluorines come in, fluorine needs 1 electron. So it's able to pull this 1 electron and share it with itself. There's another fluorine coming in, and it's able to pull that 1 electron and share it. I mean, there's sharing happening. So think about it in dot and cross diagrams. Sharing of electrons. I said there's another fluorine coming in, and another electron of iodine gets slightly pulled towards fluorine, right? And so on. So the thing is, octet expansion is a lot easier than iodine, because iodine does not hold on to its electrons that strongly. So if an atom wants to share those electrons with itself, it will be able to do that. ठीक है कि और इसको मैं draw कर लेता हूँ कि this is ये जो arrow है ना, it means this thing that a fluorine atom comes in. ठीक है, so this fluorine atom needs exactly 1 electron. So this fluorine atom needs exactly 1 electron, so it comes in and it grabs one of the iodine atoms and ends up forming a dot and cross diagram with it, right? So it's able to pull that electron and attract it towards itself. Or iodine thoda sa loose karega. Remember, whenever a covalent bond is formed, it's not that the electron gets shared between atoms. The electron is pulled by another atom very slightly, not like in an ionic bond. But even in a covalent bond, the hydrogen atom is going to drag the electron away from fluorine. So the hydrogen must have the ability to actually pull the electron slightly further away from fluorine. So in this case, the reason IF7 exists is because iodine does not hold on to its electrons that strongly. Fluorine, on the other hand, is able to attract its electrons very strongly. So when one fluorine atom आता है, if 7 fluorine atoms come in, chlorine is not willing to let go of its electrons. Is that idea clear?
जी sir.
So, Zuiba, I was just explaining that bigger atoms, they tend to usually form more covalent bonds the bigger the atom is, because they don't hold onto the electrons very strongly. So if somebody wants to share those electrons and slightly pull those electrons towards themselves, like fluorine comes in और वो electrons को ना खींच के थोड़ा सा, it's trying to pull it towards itself. So they'll allow that to happen. They'll be able to. It's going to be easy to form covalent bonds. But fluorine, when it comes to chlorine is not willing to even share electrons because chlorine is already holding on to its electrons very strongly. तो अगर दूसरा atom pull कर रहा होगा ना तो not very good covalent bonding would happen because it's not willing to let go of its electrons. So in this case, what is happening is you have easier octet expansion, less energy, needed for octet expansion. ठीक है, bigger atoms are more shielded. And so bigger atoms are more shielded and they don't attract the electrons very strongly. Don't attract electrons very strongly. I mean, we know that iodine is Cl is like 3 shells. Cl is 35 electrons. Iodine is 53 electrons. Iodine is a lot bigger. This is what an iodine atom looks like. But it's got a lot more shells. So iodine in case where the outer electrons are, if the shell is much bigger, so it can accommodate a lot of electrons, plus those electrons are not tightly held to the iodine atom. So just this very idea, this basic idea that, okay, O levels where you're stuck with the octet rule, right? Now you have to unstuck yourself with the octet rule. That the octet rule is fine up till shell number 2. Okay, shell number 2, maximum number of electrons, that's going to be 8. Shell number 3, the number of electrons that can be that an atom can accommodate, that could be a lot more than 8. You can have 18 electrons maximum. Achha, if chlorine can gain 11 electrons, it can form 11 bonds, right? So can you explain why it doesn't? The maximum oxidation state of chlorine was actually +7. So can you give me one reason why but even iodine ki oxidation states, if you look at the iodine oxidation states, the common one, that just goes up till +7. That's about it. That means it's capable of even iodine. It's capable, and remember, iodine ka jo outer shell hai na, the 5th shell. Like if I write down the electronic configuration, the 5th shell can have a maximum of 50 electrons. So the 5th shell is much bigger in size, but again, it just goes up till +7. So मुझे explain करो what is hindering? Why can't chlorine gain more than 7 electrons? As most atoms, the maximum oxidation state is usually +7. I mean, it's very rare that it goes +7 का मतलब है कि that's the number of bonds that they're forming, or the number of electrons they're gaining or losing, right? So why can't chlorine gain more than, or why can't in this case iodine gain more than 7 electrons, or make more than 7 bonds? Any reason? Common sense user, what's the reason for that? Why can't atoms usually make more than 7 bonds?
Number of electrons increase, so the force of attraction between nucleus and electrons decreases.
So वो भी है, हाँ वो भी है कि एक तो पहली बात है, you can't gain 11 electrons because that would be just too much. The nucleus is not that powerful enough. You've got a nucleus in the center, that is capable of attracting electrons, but you can't, like limit hogi na, you can't just keep on attracting electrons, right? So agar wo space 50 electrons ki bhi hai, you can't, I mean the nucleus just has 17 protons, so it can obviously not gain so many electrons. But there's another reason for that, and that is you run out of space. Iodine agar bonds banayega na, there's a, I mean if I'm the iodine atom and fluorine atoms are bonding to me, so there's a limited space available around me, right? Ek fluorine top se aa raha hai, one fluorine is coming from the bottom, one from the right, one from the left. एक सामने से आ रहा है, एक पीछे, मतलब कितने तो जगह खत्म हो जाएगी ना. Where will the, like if I want to make, like iodine has space for 50 electrons in its fifth shell, so you'll just run out of space very quickly. Like how would you be able to gain more than 7 or make more than 7 bonds? You can't do that because where would you fit all the other atoms? Is that clear?
जी sir.
So usually na, most atoms, ये मैं दिखा भी देता हूँ कि let's say, although you don't need to know about complexes, they can, just to show you a three-dimensional diagram. Complex. Just to show you an idea of this. ये कर लो, ये चलो, इसकी शक्ल अच्छी है. Just the idea that when you're making bonds, usually the maximum number of bonds you can actually form before you run out of space is 6. बहुत तो 7 हो जाएगा, that's it. So that is one hindrance. Look at sulfur over here. Sulfur is making how many bonds? That's making 2 over here, 2 over here, 5 and 6, right? So beyond that, you can't really make a lot of bonds in the first place. So इसलिए most atoms, they just run out of space, and you can't really make. So outer shell complete होने की तो दूर की बात है. If you've got 18 electrons in the third shell, it's never going to fill up. If you've got 32 electrons, it's never going to fill up. Okay, shell number 4. If I find an atom in shell number 4, just a second. What's atom? I had a periodic table. So ये shell number 4. Okay, if I talk about bromine, right? So bromine ka jo outer shell, it's got 7 electrons at the moment, and maximum electrons that it can accommodate in the fourth shell, that's 32. So bromine is never going to accommodate 32. Firstly, its nucleus is not strong enough to attract 32, I mean, extra electrons. Or secondly, it's just not, it just doesn't have enough space. So 3-4 तो कर लेगा again, लेकिन उससे ज़्यादा नहीं कर सकता. ठीक है, is that clear?
जी sir.
So बस इसमें there's just this concept that I introduced, that is that up till period 2, octet rule applies. Beyond period 2, chlorine can gain 1 electron, but it can also gain 3 electrons. It can also gain 7. It can also form 7 bonds because it's got a much bigger shell. So in sulfur, same thing. SO4 minus 2, P4O10. I mean, they're making a lot more than 3 bonds. When group 5 mein agar koi cheez hai, it's going to make 3 bonds, but not phosphorus. Phosphorus can make 3 bonds, but it can also make a lot more than 3 bonds. PCl3 exists. PCl5 also exists. It can, instead of making 3 bonds, it can also make 5 bonds. So ठीक है, ये इधर से continue करते हैं. ठीक है, we'll just draw some dot and cross diagrams of expanded octets. ठीक है. Okay, everyone.
Okay sir.
Office.